whatever you want to call it, project. So first of all, with the cruiser, the first thing we do is we have to make the rows. So start row, we convert that using this -a character. We use that to be able to make it work for in terms of integers now. So its integer row is now changed. Same thing with the start column, because the column is going to be numbered 1 through 10. We have to take 1 off so that we can use it in our matrix form. Next, the only thing we really like to do is check if it's horizontal or if it's vertical. So we put this if, and then the else would do the exact same thing, but we flip it for what we're going through and put the elements in. So what we do is we iterate a loop from 0 to the length of the board, and we take that now, and we go column. We have to check to make sure that if we add 1 to our columns so that we can go horizontally, that we aren't exceeding the bounds. So we check that now to say if it's greater than or equal to the board row.length. So if it's outside of that, then it's null, can't be placed anywhere, it's not in the board. Or if there's already something there. So in this case we have C because it's cruisers. So if there's already something there, you can't place it. And if these cases aren't met, then we just populate the current element that we're looking to place, so row and column plus I, with C. The other case is pretty much the exact same thing. Instead of columns, though, we're doing rows now. And instead of incrementing by 1 in the columns, we're incrementing rows by 1. So we return that true, and that's just how that is. So next is the battleship. It's a 2x2. So we don't have to check for rows, columns, if it's going horizontal or vertical. But instead, we do the same thing to make start row, start column. But now we have to take 2D. We have to take 2 for loops so that we can make a box, pretty much. So first of all, we'll start with the columns on the inside. And what we do here is we check, once again, the same way we did before to make sure that we're not outside of bounds with the rows or the columns with I and J, respectively. And then once more, we check to make sure that it is not already populated. And if those are the case, we need to return false, can't do it. Otherwise, the position I plus J is B, and we use I plus J because we'll go the J, the columns, so row, column, column, or row, column, row, column. So, and then once more, checking to make sure neither one is outside the bounds. In this case, return true. And the final one, the submarine, is just a singular for loop where we increment by 3, so we go 0, 0, 1, 1, 3, 3, pretty much. We're starting at the 0 position. So everything's the same, but the only thing we check this time, like the start, ready to go, is top left to bottom right. So to check if it's going this way or that way. And when we're going through it here, we check again to make sure the board length isn't exceeding the bounds. And then similarly, a different one though, and I believe it was the same, it was not okay. So down here though, in going the other direction, instead of checking if it's outside the length, we have to check if it's outside 0, because it's going the other direction now. So, but they do the same thing, where they make sure it's not filled, make sure it's within bounds, and then we just increment both the row and the column by I, because it'll be the same. It'll be the 1, 1, the 3, 3, wherever position you're going to go diagonally, has to be the same. But we do the opposite for going the other direction, so we subtract both, except for the columns will always increase. You're never going backwards columns. So if we run this, we can show the tests all pass, and our main driver, if I move myself, see my tests all pass, and our main driver shows the populated examples. So there we go.